Laron syndrome, cancer and diabetes resistance. Laron syndrome is an ultra-rare genetic condition that gives people near-total resistance to cancer and type 2 diabetes. Even though many are obese, they stay highly insulin-sensitive and rarely develop these common killers. Their bodies are naturally shielded from runaway cell growth and age-related metabolic disease. This effect comes from a mutation in the growth hormone receptor that stops normal hormone action. This results in the production of very low IGF-1, a hormone that drives cell growth. With weaker growth signals, cells are far less likely to turn cancerous, and insulin sensitivity stays high, preventing diabetes. One downside of this mutation is that it causes dwarfism, so adults with Laron syndrome are typically under 5 feet tall and have childlike features. Only about 300 people worldwide have Laron syndrome, with clusters in Ecuador and parts of the Middle East. These communities have given researchers rare insight into how dialing down growth pathways can protect against two of humanity's top killers: APOE epsilon-2 variant, longevity and Alzheimer's protection. The APOE epsilon-2 allele grants a surprising superpower, enhanced longevity and strong protection against Alzheimer's disease. Individuals with at least one epsilon-2 copy are noticeably overrepresented among centenarians. A Finnish study found that among people aged 100 to 104, the frequency of epsilon-2 carriers increased from about 9% in the general population to roughly 25% in the oldest group. Mechanistically, ApoE epsilon-2 produces a version of the apolipoprotein E protein that supports healthier cholesterol metabolism and offers protective effects in the brain. Epsilon-2 significantly lowers Alzheimer's risk and is linked to better heart and brain aging. However, there is a trade-off. Individuals with two epsilon-2 copies have a slightly higher chance, about 10 to 20%, of developing type 3 hyperlipoproteinemia, a rare cholesterol disorder that can raise blood fat levels. Porphyria, the vampire's disease. Porphyria is known as the vampire disease because some forms grant people a strange superpower, an existence made for darkness. Those with cutaneous porphyrias suffer extreme sun sensitivity. Sunlight can blister their skin, forcing them to live almost entirely at night. Over time, repeated sun damage scars their faces and tightens the skin around the lips, exposing teeth and creating a fang-like look. Some develop reddish teeth and dark urine due to porphyrin buildup, feeding legends of blood drinking. Even garlic can trigger attacks, adding to the vampire lore. This eerie link comes from genetic errors in heme production. Light-sensitive porphyrins build up in skin cells, and when exposed to sunlight, they generate toxic compounds that burn the skin from within. Historically, some porphyria patients were given animal blood or liver to replenish heme, reinforcing myths of vampires drinking blood to survive. Porphyria is rare. Some forms have only a few hundred known cases worldwide, but its uncanny overlap with vampire folklore has made it famous. Though modern treatments can ease symptoms, many patients still face painful photosensitivity, scarring, and a life spent in the shadows. Hypertrichosis, werewolf syndrome. People with this rare condition grow thick, long hair over the face, ears, and torso, giving them a resemblance to the mythical werewolf. In theory, this fur-like coverage could help the body withstand cold environments, much like natural insulation. The congenital form, often called Ambrose syndrome, is caused by rare genetic mutations or chromosomal changes that keep hair follicles active where they would normally switch off. A mutation on the X chromosome can turn on ancient hair growth pathways, producing a dense coat of hair. Fewer than 100 congenital cases have been documented worldwide. Historically, people with hypertrichosis were displayed in circuses as curiosities and labeled wolfmen or dog boys. Well-known cases include Petrus Gonsalves in the 16th century and Julia Pastrana in the 19th century. Living with this condition can bring challenges such as vision problems if hair covers the eyes, difficulty eating when facial hair grows over the mouth, and overheating in warm climates. Social stigma and constant grooming are lifelong burdens for those born with this rare werewolf trait. ACTN3 variant, super speed. The ACTN3 gene, often called the speed gene, can give people a real genetic edge for sprinting and explosive strength. It produces alpha-actinin-3, a protein found only in fast-twitch muscle fibers that power quick, forceful movements. It is thought that people fall into three groups that determine how much of the alpha-actinin-3 protein your body makes: R577R, or the RR genotype, produce the most protein. R577X, or the RX genotype, produce a medium amount, and X577X, or the XX genotype, produce the least amount of protein. People with at least one working copy have more fast-twitch fibers and excel in speed and power sports. In contrast, people with the XX genotype don't produce the alpha-actinin-3 protein, shifting muscle fibers toward endurance rather than raw speed. This tiny DNA change partly explains why some people are naturally built for sprints and others for marathons. Urbach-Wiethe Disease. True fearlessness. Urbach-Wiethe disease is a rare genetic condition that damages the amygdala, granting patients the total absence of fear. People with severe bilateral amygdala damage cannot feel primal fear, even in life-threatening situations. They might handle snakes, endure robberies, or watch horror films without flinching, like real-life Batman-level fearlessness. The cause is calcium buildup that hardens the amygdala, the brain's alarm center. With this region silenced, the fear response vanishes, though logic still tells them what is dangerous. The best-known case is SM, a woman studied for decades who cannot feel fear. Haunted houses, poisonous snakes, and even armed robbery leave her unshaken. This fearless brain is vanishingly rare. Only about 300 people worldwide have Urbach-Wiethe disease, and complete fearlessness like SM's is 1 in a million. CETP mutation, naturally low cholesterol. A CETP mutation grants the superpower of naturally low cholesterol levels by raising the amount of protective HDL cholesterol in the blood. The CETP gene produces cholesterol ester transfer protein, which normally helps transfer cholesterol between different lipoproteins. When this gene is mutated, CETP activity drops. With less CETP, HDL cholesterol increases because it is not being transferred away as efficiently. The extra HDL particles carry more cholesterol to the liver for removal, lowering overall blood cholesterol levels. People with this mutation often show a lower risk for coronary heart disease because higher HDL cholesterol helps prevent plaque buildup in blood vessel walls. This protective effect is why some drug developers have studied CETP inhibitors to mimic this natural mutation. The CETP mutation is relatively rare in the general population, but is more common in certain groups, such as some East Asian populations, where it has been linked to unusually high HDL cholesterol levels and improved heart health. DEC2 short sleeper syndrome, superhuman wakefulness. This rare genetic trait gives people the superpower to thrive on only 4 to 6 hours of sleep each night, with zero fatigue. True short sleepers wake up refreshed, full of energy, and keep this pace for life. They gain extra hours every day, turning nights that others spend unconsciously into time for work, hobbies, or creativity, an endurance advantage against sleep itself. The secret is a mutation in the DEC2 gene, which tweaks the body's sleep-wake cycle. It makes sleep more efficient by packing the needed deep and REM phases into fewer hours. A landmark study found a mother and daughter who both slept just 4 to 5 hours nightly, yet felt great. Another study on twins showed that the twin with a DEC2 mutation made fewer errors and stayed alert during sleep deprivation, while his brother struggled. Fewer than 1% of people are true natural short sleepers. Some estimates put the extreme form below 1 in 1,000. Amazingly, they show no clear health downsides, defying what we know about sleep's limits. Sickle cell trait, malaria resistance. Sickle cell trait gives people natural protection against severe malaria, one of humankind's deadliest diseases. Those with one copy of the sickle cell gene have mostly normal red blood cells, but the HBS gene makes these cells prone to sickling, becoming stiff and crescent-shaped under low oxygen. When infected by the malaria parasite Plasmodium falciparum, these sickled cells break down more easily, blocking the parasite's growth and helping the body clear it faster. This genetic defense does not make carriers completely immune, but can reduce severe malaria risk by 60 to 90%. That's why sickle cell trait is common in sub-Saharan Africa, where up to 30% of people carry it. It is also fairly common in India and the Middle East. Carriers stay healthy, but if 2 have a child, there is a 1 in 4 chance the child will inherit sickle cell disease, a serious condition with painful complications. Congenital insensitivity to pain. Pain immunity. Congenital insensitivity to pain, CIP, is another rare genetic anomaly that grants people functional pain immunity. They do not feel physical pain at all. Cuts, burns, or broken bones cause no suffering. This condition is caused by mutations in genes like SCN9A or NTRK1, which prevent pain-sensing nerves from working. One well-known case is Ashlyn Blocker, known as the girl who can't feel pain. She never cried from injuries as a baby, has endured burns and wounds without flinching, and lives without the body's natural alarm system. While it sounds like invincibility, it is actually dangerous. Pain protects us by warning us to stop harmful behavior. CIP is extremely rare, affecting perhaps 1 in 25 million people worldwide. Those with it often need constant checks to prevent unnoticed injuries or infections that could become life-threatening. Myostatin-related muscle hypertrophy, superhuman muscle growth. A mutation in the MSTN gene causes extraordinary muscle strength and size. This rare condition disables or reduces myostatin, a protein that normally restricts muscle growth. Without this natural break, muscles grow much larger and stronger than average, even without intense training. People with 2 copies of the mutated gene can develop up to twice the normal muscle mass and very low body fat, giving them a naturally muscular build similar to a real-life Hercules. The condition is usually identified in infancy because the physical traits are obvious early on. One well-known case is Liam Hoekstra, nicknamed the Mini Hulk. He could perform advanced gymnastics moves by 5 months, lift small dumbbells at 3 years old, and had 40% more muscle than typical children his age. The trait is extremely rare, estimated to occur in about 4 in a million people. Those affected are healthy and intellectually normal, but need more calories to maintain their larger muscles. Synesthesia, crossed senses, enhancing memory and creativity. Synesthesia is a neurological condition where one sense automatically triggers experiences in another. Synesthetes might see sounds as vivid colors, taste words, or hear shapes, effectively merging their senses. This blending acts as a natural superpower, often leading to extraordinary memory and enhanced creativity. For example, a synesthete might effortlessly memorize long sequences by associating each number or word with a unique color or texture. This phenomenon occurs due to extra neural connections between sensory regions of the brain, connections that typically fade away in infancy but persist in synesthetes. When a synesthete sees or even imagines numbers or letters, their brain activates corresponding color processing areas, making these experiences involuntary and consistent. Many renowned creative individuals, like novelist Vladimir Nabokov and composer Duke Ellington, attribute their artistic talents to synesthetic perceptions. The film Ratatouille visualizes Remy the rat tasting music as colorful swirls, a nod to synesthetic experience. If you want to learn more about fascinating biology and rare genetic conditions, hit like and subscribe.